Hello everyone. Our project title is Diabetic Retinopathy Detection based on Upcircle Transform. This project is presented by Mohammad Muhyiddin Ashwath, Srivatsan and Seduraman. Our project guide is Mrs. Devanagi ma'am. The main aim of this project is to identify whether the fundus image is normal or abnormal. Our objective is to reduce the user interaction by improving the segmentation performance automated and also to check whether the patient is normal or abnormal. To check and test this project, initially we open the MATLAB software. Let's run the project here. This is the entire MATLAB code for this project. For executing the code, I am going to press the run button, which will take me to the input folder, which consists of input datasets. These are the datasets we have collected for this project. This comprises of both normal and abnormal datasets. Here I am going to select the random image. After selecting the input image, it takes some time to generate the images which are required to find the final output. This is the input fundus image which is given as input. This will be converted into grayscale image. Then it will be converted into enhanced image. Then this image will be moved to the next stage which is segmentation. Image segmentation is a process that subdivides an image into constituent parts or objects. The level to which this subdivision is carried out depends on the problem being solved. That is, the segmentation should stop when the object of interest in an application have been isolated. This figure 4 is being generated after the successful completion of inpainting and a dilation process. Dilation adds the pixels to the boundaries of the object in an image. Using watershed segmentation, optic disc and optic cup can be obtained. Here the blue circle denotes the optic disc and the green circle denotes the optic cup. Then this project moves to the final stage, that is the classification stage. In classification stage, the main method used here is circular F transform. This image will highlight the optic cup. Finally, the deep neural network DNN classifier is used to check whether the input fundus image is in abnormal or normal condition. This is the final image which clearly shows the distance between the optic disc and the optic cup. If the distance between the optic disc and the optic cup is more, then the case is abnormal. This dialog box shows whether the case is abnormal or normal. In the first demonstration, we saw the case which is abnormal. Now we can see the case which is normal. So I am going to select the another image. As you can see here, if the distance between the optic disc and the optic cup is less, then the case is normal. This is the neural network training table. It shows the execution time, performance, gradient, and the validation checks of this project. Finally, the performance and the training state graphs are obtained. After the successful execution of this project, we obtained three parameters. They are accuracy, specificity, and sensitivity. This project has the accuracy of 92.6%, specificity of 46.7%, sensitivity of 65.2%. Finally, the future scope of this project is new algorithms can be used to increase the accuracy and also can reduce the training time. So it reduces the manual process and time consumption. It also eliminates the human error. Thank you everyone.